Okay, looking at number 13, which problem situation can be represented by the inequality below? So looking at these answer choices, we see a lot of decimals. So what I would say to do, go ahead and turn this fraction into a decimal. Basically 19 divided by 2 gives you 9.5. 14 and a half, 14.5. So the first one, I already marked it off, but we'll go through it. Chris and Brooklyn shop at Book Heaven, which offers reward points for each book that is purchased. Book Heaven offers 2 reward plans for the customer to choose from. Brooklyn has chosen a plan which gives her 9.5 points for each book purchased. So 9.5, that goes up here, so we'll say that this is Brooklyn. Chris, so I'm assuming Chris is going to be this situation, has chosen a plan which starts the customer with 6.75 points and rewards 14.5 points for each book purchased. So this number attached to our variable, 9.5 attached to the variable. So far, so good, right? How many books X would each have to purchase so that Brooklyn's reward points are greater than or equal to Chris's total reward points? Everything is perfect except for this sentence right here. They're saying that Brooklyn's would be greater than or equal to Chris's, but that's not what our inequality is saying. X is out. A is out. So B, Stephanie and Cole are racing against each other. So we're going to have 2 new people. Since Stephanie is faster, she is giving Cole the 14.5 feet head start. Okay, that kind of makes sense. Stephanie can run, so basically they're adding that. Stephanie can run at a constant rate of 9.5 feet per second, while Cole, so we're assuming this is Stephanie, while Cole can run at a constant rate of 6.75 feet per second. How many seconds X will Stephanie and Cole be running in the race when Cole's distance from the starting line, Cole's distance, is greater than or equal to Stephanie's distance from the starting line? Seems to make sense. This 14.5 is on the right side, 6.7 is on the right side. It all adds up, and they want to see when Stephanie's distance in the race, when Cole's distance from the starting line is greater than or equal to Stephanie's. Looks pretty good. Just to check, over the course of a year, Ryan and Tanya donate a portion of their income to charity. Each month, Tanya donates 6.75 to Stars for Children. Ryan donates 14.5 at the beginning of the year to Helping Hands, and then donates $9.50 each month to Puppies for Firefighters. After how many months will Ryan's total charity donations be greater than or equal to Tanya's total donations? Kind of makes sense, except this 6.75 and this 14.50 didn't really make much sense. So if Ryan donates 14.50 at the beginning of the year to Helping Hands and then donates $9.50 each month to Puppies for Firefighters, then how many months X will Ryan's total charity donations be greater than or equal to Tanya's? Her 6.75 is on the wrong side. Not going to work. D, Jeff plays an online computer game in which he earns 6.75 coins for each completed challenge. Juliana plays the same online computer game and earns 19.5 coins for each completed challenge. How many challenges, X, will be completed when Jeff has more coins than Julia? This one actually would work, except they're missing that 14.5. No idea where it is. So B should be your answer. Number 14, which problem situation is not represented by this equation? So F, for each week, Nina's parents give her 50 cents as a small allowance and pay her 25 cents for every apple that she picks from the family orchard. So we should say if she gets 50 cents and 25 cents, probably that's Nina. So this is going to be Bob. Bob's parents give him $2 each week and pay him 10 cents for every lemon that he picks from the family orchard. What is X, the number of pieces of fruit that need to be picked for Nina and Bob to have the same amount of money? Works for me. All the numbers add up, same amount of money, got the equal sign, but we're looking for one that does not work. G, Matthew and Michael are members of different trading cards. We've got new people. Matthew pays $2 for membership and then 10 cents for each trading card purchase. So I'm assuming that's our variable since we got that word each. Michael pays 50 cents for membership, okay, and 25 cents for each trading card purchase. What is X, the number of trading cards, yep, that each must purchase so that the total amount spent by Matthew and Michael is the same? This, it matches. They've got the variable in the right spot, they've got the numbers on the right side of the equal sign, but remember, we're looking for one that doesn't work. H, Brian has a barrel that begins with a ½ liter of liquid, so that would be 0.5, right? So it's probably this side. And fills the barrel with more liquid at a rate of 1 liter every 4 minutes. So 1 every 4 minutes. I'm assuming that's this. Ava has a barrel that begins with 2 liters of liquid, okay, and fills the barrel, so she's adding, with 1 more liter of liquid every 10 minutes, so 1/10. What is X, the number of minutes that must pass so that the barrels contain the same amount of liquid? Everything adds up, right? They're on the right side. The X is the number of minutes that must pass. That one works. So by default, J is the only one that does not work. 15, last one. Whoop, whoop. Solve the equation below. So split your equation down the middle. If you triangle circle, do it. Okay, always move your smallest variable first. So comparing 7x and 10x, 7x is my smaller of the two. So that cancels out. Rewrite your problem. I'm left with -4, always bring the sign in front with it, equals 10x minus 7x. So that gives me 3x plus 14. Okay, next move. I can't move this because then it would be over. I can't move this because there's no other variables to combine it with. I have to move this guy, minus 14. -4 minus 14 should be -18 equals 3x. Last step, divide. Last step, divide. So x equals which one?